Hello, everybody. Good morning for those of you who are sharing the smoky air in California with us. I hope you're doing okay and have your masks and filters going. But against all odds, we're continuing. And good afternoon and good evening to those in Europe. And hello to those in the future who will check this out. My name is Victoria Vesna. I direct the Art Science program, and I'm professor in the Department of Design Media Arts at UCLA. And I'm happy to introduce Eli Joteva, who is an alumni of the Design Media Arts program. She came to us from finishing a program at USC, and she is a dual citizen, Bulgarian American, wonderful, complex artist and researcher who I had the pleasure and still do to collaborate and work with now as a colleague. I love when a student of mine becomes a teacher and a colleague. There's no greater pleasure. And I'm very proud of Ellie and her work. We recently also collaborated on some animations, and she just is able to combine human and non-human, technological, tactile and non-tactile. She can get hands-on into deep programming and then get offline completely. So I'm just in love with the work she's doing, and she will present a little bit. And I should just mention that one of the reasons we scheduled Ellie right after Dr. Neinbauer from Fraunhofer Mevis is because she just became an artist researcher. So she will be working with some medical visualization, which will be amazing. So with that, welcome, Ellie, and let's see what you got for us.
Thank you, Victoria. My connection is a little bit glitchy because I'm far away and really close to the fires that are happening in the Canyon and Angeles Crest Forest. But I'm really honored to be here. Thank you for inviting me and connecting me with the STEAM Imaging Center for the residency. And to avoid further confusion with the connection, I pre-recorded my talk. So we're going to play it. I recorded it yesterday, so it's recent. But yes, and then I'll be around to answer questions and chime in with people on YouTube.
Wonderful. All right, so here we go.
Hi, my name is Eli Joteva, and I'm currently at the end of my residency at STEAM Imaging, which is where I met Dr. Matthias. It was quite an incredible and fruitful exchange to work with the scientists at Fraunhofer Mevis, and I really want to thank Victoria for connecting us and inviting me to be part of this dialogue today. So I know I'm following a very technical talk on medical visualizations, and I would like to personally offer an artistic perspective on what might happen at the limits of imaging. Because I believe that, any image, whether that be in the field of art or science, is a kind of reduction of reality. In scientific visualization specifically, there's a lot of filtration, reassignment, and remapping of data in order to highlight the important parts or to make a sensible representational model. And I really believe that it's those spaces where perception is limited or where we don't have the tools to really image what's happening that is a kind of playground for our imagination. It's this empty space of undiscovered potential that I'm really interested in exploring in my own art practice. So I found that there are a lot of assumptions that happen in the process of visualization, and we often see this with how scientific models are produced. Like a really good example of this is the imaging of an atom, like the basic building block of life, right? Which is the size that is way too small to image on a nano level. Yet we have so many diagrams and mystical representations of it, like these stock images. The size of the nucleus of a gold atom alone is approximately 10,000 times smaller than the actual size of the entire atom, and much of that is actually empty space. Another good example are the colors of the spiky coronavirus model that we're so used to seeing this year in the media. As you can see in this electron microscope image, the spikes on the outer edges of the virus are blue and not red. But the 3D rendering model that was developed by Elissa Eckert at the CDC presents the virus differently in order to be more communicative of its danger. So I think it's important to consider that despite being misaligned in the representation of reality, when these images begin to circulate in the collective unconscious, they become really accepted as a new form of truth. Like, we don't even question, what does the coronavirus really look like, you know? So I think in this sense, it's really fair to say that all scientific visualizations are a kind of reduction of reality that leaves out a lot of important complexity of what might actually be happening. And furthermore, there's so many limitations in the capacities of scientific tools to really image our reality at a high resolution. And this is the kind of space of ambiguity that leaves a lot of room for our own projections and interpretation and assignment of meaning. But it also has a lot of potential for our imaginations to take play and to really think about how these images actually take shapes in the collective human imagination. So in this short talk, I would like to take you on a journey through some of the art projects that I've worked on, where I've taken some rigorous scientific material as an inspiration or starting point for speculating on what might become possible beyond the boundaries of science or beyond the potential of what can be imaged. I mean, I often geek out on findings in the fields of neurophysics and quantum mechanics and different imaging technologies and ask myself, what can I as an artist really bring to the table that's different in these scientific findings? Can I generate inspiration and wonder at the limitations of these perceptions? And how do I process this very logically driven research through my body in an intuitive way that can maybe get to the crux of the material more viscerally when they're experienced by the viewer? So the first work I want to dive into is called Latent Projections, and just a little bit of a backup. In all of the scientific labs that I visited at UCLA, they were very frank about the fact that they assign arbitrary colors to the models that they produce. And this is something that really interested me in my early months of grad school. At the time, I was wondering if it's possible to articulate an internal experience and capture that internal point of frame of mind in an objective way. So I turned to science to look if they have an objective way of doing this. And for this reason, I began recording and transcoding brainwave EEG data to compose a series of memory portraits that resulted in the project Latent Projections, which I'm now showing you now. So I built a code that translated each band of electrical activity to its corresponding color harmonic frequency. And then I recorded my brainwave activity during different states of mind. The green one, for example, is during meditation, which produced, a high level of alpha waves and therefore resulted into a predominantly green band of color frequency. Then I would project these recorded color data portraits back onto melting blocks of ice and record this light as it would scan through the refractive frozen material. This resulted in 4 videos of recorded data projected onto ice, where either delta, theta, alpha, or beta waves prevailed, as well as a performance during which the data was projection mapped in real time to the ice blocks, and a series of photographs encapsulating different internal states of various actions, like things like I would wear the brainwave band when I was petting a cat or watching the elections or kissing someone. And I also really wanted to consider the materiality of the frozen water. I was wondering a lot about whether water can contain memory and if its structure can be actually affected by the subtle energies and unconscious thoughts of bodies. So I also began doing these portraits for my friends. I was calling them dreamwave portraits of some of my peers. And I would ask them to sleep next to bottles of water, and I would later record their brainwave data while they were thinking about their dreams. And then I would project that data back onto the frozen dream water that they slept next to. And there's something very interesting about the different crystalline structures that would appear in the different waters, which of course is also determined by the pollution that exists in the water. So all of those elements producing a kind of material internal portrait of somebody trying to remember their dreams or their memories. And what I realized after doing this project is that at this like really early stage of working with data, I was attempting to be very logical and pragmatic. I was treating it more as like a science project. I really wanted the color harmonic frequency of the brainwaves to be like exactly mathematically mapped and translated to the specific color band. And what I quickly realized after presenting my work to my peers and my professors was that it didn't really matter if the science and the math was correct. That perhaps it was enough for me to tell you that this is a portrait, an internal portrait of me remembering kissing someone, and that would trigger something in your own mind. The poetics of the title and the color composition actually do a lot of heavy lifting in structuring our experience of an image. I also realized a lot about the limitations of brainwave signals, which are often noisy because they're gathered on the scalp of the head, and I was also very interested in exploring memory. The memory center of the brain is located in the hippocampus. So if I really wanted to get precise data signals, I would have had to stick electrodes into that part of my brain to really get a clean brainwave signal. And this led me to the research done by the neurophysics lab at UCLA, led by Mayank Mehta, who later became one of my thesis advisors. In his lab, they actually built a really incredible multi-sensory virtual reality environment so they can study how memory is formed in the brain. And there, they actually do stick electrodes into the hippocampus and regions around the hippocampus to study the EEG oscillations in the process of memory formation. They basically have these rats running around in gyroscopes in VR environments, and they study what happens when they expose them to different auditory and visual cues. Their paper, Do the Legs Know What the Tongue is Doing, actually revealed some really fascinating results in embodied cognition. More specifically, they found that their bodies were aware of reward targets they had learned existed in a virtual space even when their legs could not consciously register to stop. So the way they would measure this is by placing virtual reality targets throughout this space and allowing the rats to remember that virtual space, and also meanwhile monitoring their salivation and rewarding them with sugar when they would reach a target. And later, when they removed those visual cues and only gave them auditory cues, the rats would not stop at the locations of the target. However, their mouths would salivate as they would pass through them, meaning that the auditory signal was enough to signal to the brain that that is a space where a reward usually would come. However, the body wouldn't consciously stop to receive the reward. So it's actually a really incredible proof of embodied cognition, and something that I'm incredibly interested in, how memory can be stored in the body and accessed through an environment. Some of the other research that they revealed is that 60% of the hippocampus completely shuts down in VR, which is quite possibly because the hippocampus actually needs more than one or two sensory inputs to build an internal map of a space. Another fascinating component of their research deals with their monitoring of gamma and theta waves. The coupling of those two waves, they found, actually influences the construction of place cells in the brain, which are kind of like internal map targets in the neurons. They discovered that theta functions like a kind of clock, giving precise 10 millisecond time to gamma, which the two signals are actually really needed for memory synapses to form. When I learned this, I was like, oh, how fascinating that the vibration of gamma, which is often prevails in sort of genius invention moments, really needs the slowest unconscious theta wave that usually is produced when we're in deep sleep to synchronize neuron spikes and form a memory within a place. So I really wanted to work with these two brainwave signals, and I built a tool that actually isolates them and also allows me to bridge this internal world with the external one. I developed this performance and wearable prototype for the project Embodied Landscapes, where I isolated theta and gamma live feed EEG waves and translated them into their corresponding color harmonic frequency, orange for theta and purple for gamma, in real time. So this wearable prop really allowed my body to move more directly and interact within its environment. And in this first performance that I'm going to play for you now, I really wanted to see if I can tap into my own body memory by navigating a familiar landscape with my eyes closed. I was very interested in illuminating a landscape with my biometrics and the process of creating an image without having the visual input of the process of creating that image. So you're watching me attempt to climb a tree that I remember very well with my eyes closed, and the brainwave signals that my body produces as I'm doing that. I've always been interested in memory, and not so much as memory as a reference to the past, but rather as a kind of imaging imagination that happens in the present. And I've always asked questions like, how is memory formed, accessed, and rewritten through the present moment? And how is memory embodied and enlivened through our sensory experiences? Another piece I want to show you is called Inter-I, which was created during a time I was deeply invested in new materialism theories and thinking a lot about the quantum fluctuations that happen in the body. This piece is actually an ode to the death of a friend who was taken by the Black Sea, and I also helped pull someone out of that sea earlier that year and save their life. So I was thinking a lot about where consciousness goes after it leaves the body, and in my imagination I became very haunted by this image of an electric body, or a body that exists between the physical and the ethereal. A body that's composed of electrons, photons, and waves, all affected by the environment. So this was a large projection piece that was installed in a suspended rear projected way, and the video itself wasn't produced with any computer graphics. It's actually made from the recordings of the full moon and the Black Sea that are projected onto my own body as I'm kind of performing these movements of mourning. I also want to share this project with you that's dealing more with the memory of matter and how memory is accessed and rewritten in the present moment. The project is called MNEMOAWARI, and I started it in 2017. The title comes from a combination of the word Nemozin, which is the goddess of memory, and Mono no Aware, the Japanese word for the beauty found in the sadness of a fleeting moment. The first iteration was composed of 3 cryosculptures comprised of organic materials that are gathered from different locations, a bit like landscape portraits, you could say, as well as 3D scans of those sculptures right when they would come out of the freezer. think with this project I wanted to call attention to the fleeting nature of our material experience, as well as the kind of ghostly digital remains that happen after our experiences are lived. There's also a kind of beating of the present, so the sound of the melting drops are captured with contact mics underneath the sculptures as they melt, and they're amplified in the space. And these sounds are also fed into a VR piece, which when you enter it, you can kind of enter one of the 3D models, and the live sound becomes an interrupted signal of the scan. So you kind of have this real-time feedback of reality decomposing as you're inside of this virtual space. I am very interested in the connection between the material and the virtual or the digital. I continued to explore 3D scanning with my MFA thesis project, where I really geeked out on the technical elements of 3D scanning, more specifically LiDAR-based scanning, which involves infrared light to produce an image. I was also doing a lot of research on photography and early imaging techniques, which led me to the cyanotype and Anna Atkins, who was the first woman, considered the first woman photographer to ever publish a book that was actually later used by botanists for her imaging of plants using the cyanotype method. And it's a chemical process that involves the exposure to UV light, ultraviolet light. So I thought how interesting that the current technology we have for imaging includes infrared light, and one of the earliest ones is on the ultraviolet spectrum of light. And so the project, my thesis project, really became about combining these two invisible bands of the light spectrum into one project. So I produced a number of 3D scans of live plants, which then turned into these prints that are actually multiple views of the same plant. So you kind of have a collapsing of 3D object into planes, and the squares are just the data point. These 3D plant scans were also integrated into a video projection piece, which was installed as a rear projected light piece again, which is all of the plants amorphously moving in and out of each other. I think at the time I was reading a lot about quantum mechanics and the zero-point field, which is what the piece is named after, being this field where quantum physicists can actually measure subatomic field fluctuations even below absolute zero, speculating that perhaps there's a constant activity even in the most frozen state of matter. And the particle simulation that I did with the 3D scans really allowed me to begin to imagine how I perceive reality as a sort of shape-shifting, amorphously changing landscape. that is always colored by our perception and emotions. Just to finish off this talk, I want to briefly discuss intra-being, which is a project I'm developing through the Fraunhofer Mevis residency. I'm again looking at memory, but through a more clinical lens, and more specifically, I'm exploring virtual patients, how they are used in simulations that train clinicians to perform on real bodies, that allow clinicians to produce an image in their head before they operate. So a kind of relationship to the virtual body as a training ground before touching the real. I'm also looking into population studies that are done on virtual patient databases, which include thousands of scans of different subjects and that are anonymized and looked at for research purposes. So thinking about the collective body as a kind of body that can give insight and information about an individual subject. It's very fascinating that this type of population study can actually allow for the discovery of what they call biomarkers, which are kind of imperfections in the MRI scans that could potentially develop into future diseases. I'm thinking a lot about the use of these collective databases as revealing something inherent about the future. Perhaps they can be thought of as memory echoes of a body from the future that allows us to do something about it now. Or perhaps it completely collapses the probability that entraps the body to develop in these assumed ways. There are many question marks that came out of the residency, but one very specific, maybe one that I'll leave you with, is that we're so used to seeing MRI images as if we're really looking at the structure, the physical structure of something. Some of these images of brain fibers, for example, which are meant to show us where axons are actually, what they're actually showing is the movement of hydrogen atoms along those fibers. The way that MRIs generally work is by changing the spin of hydrogen atoms that are more susceptible to being energized than other atoms in the body. So what we're actually looking at when we see images of brain fibers are an assumption that that is where the brain fiber is, because MRIs actually only image hydrogen.
Elizabeth,
So
you
these are
have
just
to
some
wait
first
a little
sketches
bit.
of what I'm thinking about in terms of a feeling of the work, which will come out next year at Ars Electronica. But they are thinking about all the particles and atoms that exist around our nervous system and potentially can be gateways for our memories to open up into and outside of our bodies. I think that's it for today. Thank you for watching my talk, and stay tuned.
So, Ellie, you've had a lot of fans there on the side, a lot of hearts, a lot of people saying how inspiring. It must be so nice to see how people respond to you.
Yeah, thank you everyone for tuning in. I know a day attention economy is tough these days and there's lots to watch online, so I appreciate you being there in real time with me.
Is there anything you want to say?
Yeah, and thank you, Victoria, for having us. And currently we're actually doing another live stream of the photogrammetry workshop with Zeynep Abbas. So you're welcome to join that. And you saw some newer work that will be shown at the Unearthed exhibition at of Super Collider, which is happening as a panel on Sunday, as well as the Alien Stardust official premiere with Victoria, who I had the pleasure to produce the animations for. So I'm really excited about all of Ars Electronica, and thank you, Victoria, for having me here.
Thank you, Ellie, and breathe and breathe and breathe.
Breathe clean air.
Hopefully these fires stop and we can breathe and move, and then the COVID slows down and we can see each other. But for now, this is what we can do. And thanks for taking the time and being such a great collaborator.
I appreciate you too. Thank you. Take care. Bye-bye.
Bye.